All right, so second part of our section on factoring here. In the previous class, we looked at all this stuff, and what I want to talk about now is factoring completely. It says factoring a quadratic expression completely sometimes means factoring the GCF before factoring the quadratic. So I have an example, 2x squared plus 16x plus 30. And I'm going to show you 3 different ways to factor this, right? The first 2, all 3 of them work. All 3 of them are mathematically sound. But I'm going to recommend the third method. So you don't necessarily have to write down the first 2 methods, but it's important to see how they all work a little bit differently. All right, so first thing, 2x squared plus 16x plus 30. So I recognize this is a quadratic, and I'm going to factor it into 2 binomials, so I set up my parentheses. My second sign is positive, so whatever that first sign is, it's going to go in both sets of parentheses. So I have a plus and a plus. Now factors of 2x squared can only be 2x and x, right? So I'll go 2x and x. Factors of 30, well, could be 30 and 1, could be 15 and 2, could be 6 and 5. Right, I have some options here. So doing some of that foiling in my head, let's see. All right, so if I put the 5 here and the 6 here, then my outside terms give me 10x, and my inside terms give me 6x, and those combine to give me the 16x that I needed right there. All right? So I know that my factors 2x plus 6 times x plus 5 are indeed factors of my original quadratic. However, if I look at the 2x plus 6 term, there's still a common factor there. 2 goes into 2x, and 2 goes into 6. So if I'm factoring completely, I need to factor that 2 out. So I factor 2, and I'm left with x plus 3, and then I have my x plus 5 factor as well. I cannot miss factoring that 2 out as the common factor there. All right, so let's do this problem again a slightly different way. 2x squared plus 16x plus 30. So I'm going to factor it into my 2 binomials. Again, I'm going to have a plus and a plus. And again, 2x squared is going to factor into 2x and x. Now, the pair of factors that I forgot to list the first time are 10 and 3, right? 10 times 3 would give us this 30. So we need to consider those, and in this case, we're going to use those. Because if I put the 10 here and the 3 here, outside terms would give me 6x, inside terms would give me 10x, and that would combine to give me the 16x that I need. So a little bit different than how I did it the first method. But now looking at those factors, I again see that there's a 2 in both of those, right? So I can factor that common 2 out again. And I'd be left with x plus 5 times x plus 3. Now you notice that both factors here and here are now the same, right? Even though we went about it a little bit differently. Now, I propose that you use a method where you look to factor the GCF first instead of last, how we did it here. So let's look at how that would play out. So I start with my 2x squared plus 16x plus 30, and I look for that common factor right off the bat. and I see that 2 goes into all of those terms, right? So I can pull out that 2, and I'm left with x squared plus 8x plus 15. Now, I think this is a better way to factor because now the quadratic that I'm factoring inside the parentheses has a leading coefficient of 1, which puts it in that easy category. So I set up my parentheses. I'm going to have plus and plus. I'm going to have x and x. And now factors of 15 are going to be either 15 and 1 or 5 and 3. And I like the 5 and 3 because it immediately gives me that 8 right there. So I have 5 and 3. And you can see it's the same as what I ended up the first two methods. But again, I propose this is easier to look to factor the common factor first instead of last, because it'll help you avoid missing that common factor, and it'll help you in that you're factoring an easier quadratic with that leading coefficient of 1. All right, so the last thing that I want to talk about is recognizing and factoring a difference of two squares. All right, remember, the difference in math is the answer to a subtraction problem, right? Now notice that we are subtracting here, we are subtracting here, and we are subtracting here. So that's why we call it the difference. Two squares, the difference of two squares, meaning two perfect squares. Like the number 4 is a perfect square, right? Because it's 2 times 2. And the number 9 is a perfect square because it's 3 times 3. And 16 and 25 and 49 and 64 and so on, right? They're all perfect squares. Well, something like x squared is a perfect square because it's x times x. So when we say the difference of two squares, we are saying subtraction of two perfect squares. There's a perfect square, there's a perfect square. Here's a perfect square, because 9 and a squared are both perfect squares. 16 is a perfect square. 25b squared, that's a perfect square. 25 and b squared. And then obviously 4a squared, perfect squares. Okay? So we need to be able to recognize the difference of two squares because they're really easy to factor. Okay? Set up my parentheses into two binomials. The sign that we see there is actually the second sign of the quadratic. So we automatically have a plus and a minus. And now we just take the square root of each of these terms. The square root of x squared is x and x, and the square root of 9 is 3 and 3. So x squared minus 9 factors into x plus 3, x minus 3. Now we go to the second one, 9a squared minus 16. Set up my parentheses. I know I'm going to have a plus and a minus. And 9a squared factors into 3a and 3a. And 16 factors into 4 and 4. So we have 3a plus 4, 3a minus 4. And then the last one, 25b squared minus 4a squared. I have a plus and a minus. 25b squared factors into 5b and 5b. And 4a squared factors into 2a and 2a. So I have 5b plus 2a and 5b minus 2a. Usually, once you get the hang of it, the hardest part of factoring a difference of two squares is recognizing a difference of two squares.